Okay, video 7. Oh, here is a why do some of these have calculator icons and other ones don't? That is just annoying. Some of them definitely needed calculators. Like number 1, definitely needed a calculator. Okay, number 38. The table of ordered pairs are the solutions to which of the following? So these are XY ordered pairs. Which one does this match? So it looks like angles are in the output. These are angle measures. The angles are in the output, so inverse trig. Angles in the output, inverse trig. I can now rule out my non-inverse trigs. A and C are off the table. Now we need to figure out, is it sine or cosine for inverse trig? Easiest way to check is check the y-intercept. The y-intercept here is whenever this is 0. 0, 0. Well, 0, 0 is this point right here. And the function that goes through the midline at 0, 0 is absolutely sine. So this should be inverse sine. Okay. The function f is defined by, I'm not going to read that whole thing, but just from the looks of it, there's a vertical shift of 70. There is an amplitude of 5. This is a period of 2 pi over b, so this is a period of 300. Oh, okay, so 365 tells me this should be like a year, something to do with years, days, and stuff. And then t minus 90 is just a shift for put it into the right month to, okay, from 0 to 365. Great. Function f models the temperature of water in a lake in degrees Fahrenheit since January 1st. So yeah, it has something to do with years. 365 usually dead giveaway for that. Based on the model, the predicted temperature of the water will be greater than 70 degrees Fahrenheit for approximately how many days? So I need to figure out, when does it go above 72 degrees? So we need to know, when is 72 equal to, technically we want 72 to be less than. When is it less than? You can do equal to, it doesn't really matter at this point. 70 plus 5 sine of all this stuff here. I'm gonna call this U for now. Call this whole thing in here U until I get to it, just to save some space. U substitution is great. Yay. So let's start by subtracting 70 from both sides. Actually, why are we doing it this way? Check this out. Calculator. Desmos calculator works for this as well. Calculator. Here's what we'll do. Okay, let's see if this works. I'm trying something I've never tried before. Let's see. Desmos calculator. Oh, I hope that shows up. That's going to be so cool if it does. So we got a Desmos calculator. Make it a little bit bigger. And what we could do here is type in our entire equation, which is 70 plus 5 sine. Why do things on paper when I have a fancy calculator at my fingertips? 2 pi over 365. 2 pi over 365. T90 in parentheses. T minus 90 in parentheses. There we go. Not T. It doesn't like T, so we'll just call it X. And that should graph it. And it does graph it, but we can't find it. So there is no red exclamation mark here. So it's got, oh, there's the guy right there. There he is. And we want to know how many days is it above 72 degrees. So I want to know y is equal to 72. Gives me this. And if I go over here, it is above 72 degrees from here all the way to here. It is above 72 degrees in between on this interval. So 248 to 113, subtract that, 248 minus 113, and we get 135 days. So it should be 135 days. Let's see if we can hide this Desmos calculator, and let's see if I have 135 on my list. I got 134, so it's probably just a rounding error. Close enough. Bam. The function f is given by f of t sine squared minus 1. For how many values of t does f of t equal 0? So when does sine squared t minus 1 equal 0? So let's add 1 to both sides. When does sine squared t equal positive 1? Square root both sides. So that gives me case 1. Sine t is equal to positive 1. And case 2, sine t is equal to negative 1. So the square root of 1 is positive or negative 1. Then I need to take inverse sine of both. Well, no, I don't. Like, I could find the exact value here if I wanted to, but how many values does it happen? It happens at least once, and if it's a periodic, if it happens once, it's going to happen a lot. So it's got to be infinitely many. Inverse sine of t is, if you want to finish this off, t equals inverse sine of 1. That is going to be, sine is 1 at pi over 2. So this will be pi over 2 plus 2 pi k. So there are an infinite number of cases where this happens, just in case 1. Yay. Ooh, rocking horse. Cool picture. Breaks the monotony of numbers. Okay, the number of moose. Why is moose plural? That's so weird. Like, why not goose is goose? That's not plural. It should be moose and meese. Went off on a tangent there. The number of moose in a park is modeled by the sinusoidal function m, given by this equation right here. So I got a vertical shift, I have an amplitude, and I have a period change. So it has to be something to do with yearly back and forth. Yep. Which of the following statements is true? M is decreasing on the interval, so we need to figure out when is it increasing or decreasing. So there's no phase shift, so it should be just a normal sine function with the everything taken apart. So b is 2 pi over 365. If the period is going to be, this tells me the period is equal to 365. If the period, one period, is 0 to 365, and this is a sine graph, so sine starts at the midline and will end at the midline. Positive sine graph is going to go, and then the halfway point will be a 0, or goes to the midline again. And since it is positive, there'll be a max here and a minimum here. So it should go like this right here. Now, each of these points is 1/4 of the period. So from here to here, this would be day 183-ish, 182, 183-ish, half of 365. Half of this is 91. So this should be day 91. And then halfway in between here should be roughly 273. I can do that in my head quickly because 360, these are like the cardinal points. 90 degrees, 108 degrees, 270 degrees, 365 degrees. Pretty close. Okay, so M is decreasing on the interval 0 to 1, 8. Nope, this is increasing right here, so it can't be A. B is decreasing on the interval 92. Sure, why not? 92. So decreasing. We are decreasing here all the way to 273. Yep, that's it. And just to check, M is decreasing 183 to 3. Nope, it increases here, so it can't be that one. Decreasing from 0 to 90. Nope, that's increasing. So has to be B. Hooray! 42. The figure shows a child leaning backwards and forwards while riding a rocking horse. The height in inches between the level of ground. Sorry, the level of ground. So this is. So we're measuring the height right here. We're measuring the height of point T over time. And it gives us this function here, where T is the time since the child first leans furthest back. So if the child is leaning furthest back, this point starts at a max. Okay. Oh, and it has cosine already. Great. If the child rides the rocking horse for 5 minutes, and T, I'm assuming is in seconds, how many times will P touch the ground? In inches between the height in inches, where T is the time since the child first in seconds. So yeah, we're in seconds. So we know how many times does it touch the ground. How many times will it touch the ground? So the period here, so first we need to figure out the period. How long will it take to touch the ground? The period is equal to 2 pi over b, which is, and b is pi over 3. Keep, change, flip. And we should get a period of 6 seconds. So every 6 seconds, it will complete 1 lap. So in 6 seconds, 0 to 6 seconds. In 6 seconds, it starts at a max. It will come down, touch the ground here, and come back up. Touching the ground will be the minimum, right? Touching the ground will be the minimum. So how many times is, so this, it touches the ground 1 time per period. It's always good to sketch this, by the way, because if this would have dipped below, you would have 2 times per period, but because it's at the very minimum, you have it 1 time per period. So how many periods happen in 300 seconds? So in 300 seconds, divided by 6, so this is going to end up being 3 divided by 6 is just 1/2. So 100 over 2, which is 50. This should happen 50 times. Always draw your pictures. Pictures are so awesome. Okay. Let's get one more page on this video, and then we'll finish it up with video 8. I might be able to get through all those on video 8. Let's see. Okay, so 43. The graph of the trigonometric function f are a line given in the xy plane. The point of intersection of AB occurs when f of x equals b. Yeah, so f, technically this would be f of a equals b. For which the following system equation could the point BA be a solution? So we need to find out when BA is a solution. The graphs of the trigonometric F are in line, and a line are given. So here is That's the function. And this is the line. This is a horizontal line, so this line is equal to y equals b. Y equals b? Yeah, y equals b. Yeah, y equals b. And we need to figure out when is this going to be, what's the inverse of solution? So the inverse, if y equals b, if we invert both of these, x should equal a. Oh, that's not an option. Oh no, inverting these. Hang on. Oh, BA. We invert both of these. So if we invert these, x equals b should be an equation. So that one is here. That one is here. So x is equal to b. That one would work. Y is equal to a would also work, but there's not a y equals a, so those two go out. And we should figure out if this is going to be a sine or cosine inverse. So we're starting at a max and going down to a minimum. So this is a cosine graph. So we would have to invert cosine. So it should be b. 44. The function f is defined by f of theta is equal to cosine of 2 theta. So we have a period change here. The period is 2 pi over 2. So the period should equal pi. Which of the following is the equivalent expression for f of theta? Oh, cosine of 2 pi. So this is trig functions. So cosine of 2 theta. That should be, so cosine of 2 theta has the double angle formulas. This is going to be 1 minus 2 sine squared theta, or it's going to be 2 cosine squared theta minus 1, or it's going to be cosine squared theta minus sine squared theta. So either three of these can all equal cosine of 2 theta, according to our little cheat sheet. So it's not this one. 1 minus 2 sine squared. It should be C. 45. The function is given by, so we have a vertical shift of 5. And I have an amplitude of 7. Which of the following on the interval pi to 2 pi does f of theta equal 0? So I need to find when 5 plus 7 cosine x is equal to 0. So we have to get x by itself. Subtract 5, 7 cosine x is equal to negative 5. Divide both sides by 7. Cosine of x equals negative 5 over 7. Take inverse cosine of both sides. X should be equal to inverse cosine of negative 5 over 7 plus 2 pi k. Right, that's all we got, right? That's why is there this? Why is this here? That's annoying. I don't like it. It's A. There shouldn't be any kind of vertical shift here for the inverse part because all that gets tucked into the x values for the inverse. For what value of x on the interval pi to 2 pi? And cosine, yep, there we go. Oh, hold on, I know what this is now. Wait a minute. This changes the quadrant we are going to be in. So let's make sure this is in the right quadrant. Inverse cosine, this only outputs into quadrants 1 and 2. because this is negative, this is in quadrant 2. This is quadrant 3, 2, 4. So I'm in the wrong quadrant. It is not A. I'm in the wrong quadrant here. I need to jump to a spot where cosine's the same value. And cosine still has to be negative, and cosine's also negative in quadrant 3. So that is a negative angle. So I want to do 2 pi minus my negative angle. So it should be 2 pi minus arc cosine. That'll put me into quadrant 3. Remember, arc cosine is always an angle. Arc trig functions are angles, so making it a negative is a vertical shift. So I want to go from quadrant 2 to quadrant 3. That's a vertical reflection, so make the angle negative. Okay, I will see you guys in the final one, part 8.